Hey there, space explorers, and welcome. Get ready because today we're going on an awesome adventure to figure out the most powerful invisible force in the whole universe. And we've got the best guides to help us out. Say hello to the super curious explorer Gravitas and her brilliant robot sidekick, G-Bot.
All right, let's jump right in. Our friend Gravitas has a question, and I bet you've wondered about it too. You know when you throw a ball way up high in the air, why does it always come back down? Why doesn't it just, float away? Why do things always fall down?
Well, you know who has the answer? G-Bot, of course. He's telling us there's an invisible force pulling that ball, and you and me and everything down. It's called gravity, and you can think of it like the universe's superglue, holding everything together so it doesn't fly apart.
So what's the deal with this amazing pulling force? Our first mission, should we choose to accept it, is to understand gravity, the big pull. Let's do it.
So, here's the secret to gravity. It all comes down to, well, stuff. Everything in the entire universe, from a tiny little pebble to a gigantic planet, is made of stuff. Scientists just have a fancy name for this stuff. They call it mass.
And here is the first huge rule you gotta know for our adventure. The more mass, or stuff, something has, the stronger its gravitational pull is. An apple, for example, has a teensy tiny bit of gravity, but it's so small we can't feel it. But our planet Earth? It has a lot of mass, and its super strong gravity is what keeps our feet planted right here on the ground.
The cool thing is, gravity isn't just random. It actually follows a couple of really simple rules. A super smart scientist named Sir Isaac Newton helped figure them out. So let's check out the two big rules of gravity. It's all about mass and distance.
And boom, here they are. Super simple, right? Rule number 1, the more mass something has, the stronger its gravity. That's why we orbit the huge sun and not the other way around. And rule number 2, the closer things are, the stronger the gravity. The pull gets weaker as you get farther away. It's kind of like a magnet. You know how it gets way stronger the closer you get? Just like that.
All right, now that we know the rules of the game, let's blast off. It's time to see how gravity stretches its invisible arms all across the universe, from right here in our backyard all the way to the farthest stars.
So let's just imagine for a second. We all know how high we can jump here on Earth, right? But what if you could take that exact same jump on the moon? Or what about on the gigantic planet Jupiter? Do you think it would be any different?
Well, check this out. Here's a mind-blowing secret. The amount of stuff you're made of, your mass, that never changes. You're always the same amount of you. But your weight, that can change. See, weight is just how we measure the pull of gravity on your mass. So on the moon, with its weaker gravity, a 100-pound kid would feel super light, weighing only 17 pounds. You could jump so high. But on massive Jupiter, you'd weigh 253 pounds. Good luck trying to jump there.
Thinking about all this makes you wonder, how did people figure all this stuff out anyway? Well, for a long time, it was a total mystery. Then, two incredible thinkers came along and totally changed the game. First up was Sir Isaac Newton, who figured out the rules of gravity. Then, way later, Albert Einstein came along and figured out why it works the way it does.
Newton's big idea was totally revolutionary. He realized it wasn't just the Earth pulling on the apple was also pulling back on the Earth. Every single thing in the universe is gently pulling on everything else. It's like a giant cosmic tug of war happening all the time between every star, every planet, and even every person.
But then, Albert Einstein showed up with an idea that just bent everyone's minds. He said, hold on, what if gravity isn't a pull at all? What if big, heavy objects actually bend and curve the very fabric of space around them, kind of like a heavy ball sitting on a stretchy sheet?
Whoa. And this is the perfect way to picture it. Let's call it the trampoline universe. First, just imagine space as one giant stretchy trampoline. Now, 2, you place a heavy bowling ball. That's our sun, right in the middle. See how it makes that big dip? Okay, 3, now you roll a little marble. That's the Earth nearby. And 4, what happens? The marble just follows the curve in the trampoline made by the bowling ball. That's an orbit. So it's less of a pull and more like just following the path that's already there.
Okay, so bowling balls and trampolines in space. That's super cool. But how does this cosmic force actually affect us, every single day? Well, it turns out gravity is basically your silent superpower, always working for you behind the scenes. So what's on gravity's daily to-do list? Well, first, it keeps your feet on the ground so you don't just float off. Super important. It also holds our atmosphere, all the air we breathe, close to the Earth. It keeps our planet in that perfect dance around the sun, giving us years and seasons. The moon's gravity pulls on our oceans, creating the tides. And maybe the biggest job of all, every star and planet, including our own Earth, was born because gravity pulled giant clouds of gas and dust together. Without gravity, we literally wouldn't be here.
And if you thought that was amazing, get this. Einstein actually predicted that gravity is so strong, it doesn't just bend the path of planets, it can actually bend light itself. That means a massive galaxy can act like a giant magnifying glass in space, warping and stretching the light from things that are hidden behind it.
And that brings us to the ultimate champion of gravity, a black hole. This is what you get when you squish a ton of mass into a super tiny space. It creates a curve in space that's so deep and its gravity becomes so strong that absolutely nothing can get away once it gets too close. Not even light.
Whew, that was a ton of amazing information, right? So let's do a quick power-up. It's time to recap the 5 gravity superpowers that you now officially have stored in your brain.
Okay, team, let's lock this knowledge in. Number 1. Gravity is an invisible pulling force, or a curve in space. Number 2, more mass means more gravity. Remember the bowling ball? Number 3, more distance means less gravity. Easy enough. Number 4, it's the cosmic glue that holds our planet, our air, and our oceans right where we need them. And number 5, it's the master builder of the universe, creating every star and holding it all together. You got this.
So, we've learned just how important gravity's rules are for, well, everything. But what if you could be the boss of gravity for just one day? What would you do? Would you make it so you could float to school, jump all the way to the moon, let your imagination run totally wild? Thanks so much for joining our gravity adventure today, everyone. Keep looking up and never stop asking questions.